Okay, project interfacing PC joystick with Arduino. How can we control an Arduino or something connected to an Arduino? Say for example X and Y servo system with PC joystick. We have an Arduino. However, PC joysticks are connected like that, potentiometers, and from the schematic, pin 1 is VCC going to one end of the potentiometer, and the middle section of the potentiometer, and the output or the other end goes to the X1 and the Y1 for joystick 1. So you can't read a variable voltage from that connected to analog input. So what do? Solution: that variable resistor 1 and 2, X and Y, joystick 1, connected to a 555 timer, and it replaces R1. So when you vary R1, fundamentally changes the frequency of the output for the 555 timer. Normally they would put a potentiometer at R2 between the charge and discharge pins 6 and 7, and that R and that C gives you your time, which 1 over your time gives you your output frequency. In this case, I vary R1. That changes the frequency in a very small range. That small range, I can actually read that into logical pins of the Arduino. So I use pulsing, measure the frequency, and here I have 1555 and an identical circuit again, 555 timer, and this is my joystick interface. Oh, it looks messy with wires all over. Trust me, that's how it's connected, right? So orange wires, those are my X1 and Y1 connected to the resistors R1 for each timing circuit. And as I vary the frequency, the output at pin 3 for first one goes to pin 7, output goes to pin 8. So when I turn this on, I have a small Arduino script. You can probably see it here. That's going to read the buttons. These white connectors connected to pin 2 and pin 4. Those are my button 1 and button 2. So let's give it some power from power supply. And let's bring up, as you can see, my Arduino is on and it's not transmitting, and we're going to bring up, oops, sorry about that, we're going to bring up our monitor, our serial monitor. Now you can see there's an output from the Arduino, right? Here we're transmitting our joystick, our timing circuit, and now we're going to look at the output. Now while we're observing the output, I'm going to be interfacing with the joystick. So you see button 1 goes 0. That's because it's being depressed at this moment. it's being released. It goes back to 1. Button 2 is being depressed as it goes to 0. When I release it, it goes back to 1. Now look at X and Y. When I move the joystick, you would notice these constants are going to change. These are actually the time period, the number of pulses read into the pulse input. So there you can see Y has decreased, right? And you will see it go back to 6609, the 6614. It's not stable, and here it's being pulled in the opposite direction, and you can see it goes up. So it actually reads the change for that frequency. That's why. Now I'm going to play back in the neutral position, and now I'm adjusting X. If you look at X, you're going to see a change. It went up. It's now 665054 around there. And put it in the opposite direction, you will see okay, so it's 6, 7 and 5, and it goes down. Y, X, 6, 7, 6, 5, 6, 4. And here it's 5, and it goes down. So as you can see, you can see the change. It's 6, 7 now. Back to neutral. It's 6, 6. Opposite direction. 6, 6. We're not reading a decrease. 6, 5 is not enough. Unlike Y, we have 5, 5, 9. Neutral is 6, 6, 0, 8. In the opposite direction, we have 6, 6, 5. Right? So that is how you control or use a regular PC joystick with an Arduino.